Start out with section 3, that is page 42 of the PDF. This first section, section 3, is a non-calculator section. Section 4 is, so I'm going to stay away from the calculator on this one. Okay, Salim wants to purchase tickets from a vendor to watch a tennis match. The vendor charges a one-time service fee, processing the purchase of the tickets. The equation T equals 15n plus 12 represents the total amount T in dollars Salim will pay for n tickets. What does 12 represent in the equation? So if we think about this, a lot of these questions usually want you to use some kind of knowledge of equations or systems to model what's going on here. So if we look at this equation here, T equals 15n plus 12, right? It looks a lot like our y equals mx plus b equation, right? We have the slope or some coefficient, in this case the m, the slope would be our 15, and the 12b would be our y-intercept. If you think about what our y-intercept looks like on a graph, right, it's where we start on the y-axis before we move anywhere at all on the x-axis. So it's kind of like a head start, I guess. And if we think about what that means, in this case, for this problem, it says that we have a one-time service fee, right? So that service fee is independent of how many tickets we buy. It doesn't matter. It's like our, technically if we were paying for 0 tickets, we'd have to pay $12. I mean, that wouldn't exactly make sense. But our one-time service fee definitely represents that 12. So that one-time service fee makes sense. Like I said, the service fee is independent. You could buy 1 ticket or you could buy 100 tickets. You still got to pay that $12 service fee. It's independent of the number of tickets that you pay. So if you look at the answers here, A says the price of 1 ticket in dollars. No, that's definitely not right. That would be 15. B, the amount of the service fee in dollars. That seems right. Let's look at the other answers. C, the total amount in dollars Salim will pay for 1 ticket. No, that's T here, so no. And D, the total amount in dollars that Salim will pay for any number of tickets. I'm sorry, D would be that T, but C is not right either. So our answer is B. That makes sense. That's what we were looking for. All right, number 2. A gardener buys 2 kinds of fertilizer. Fertilizer A contains 60% filler materials by weight, and fertilizer B contains 40% filler materials by weight. Together, the fertilizers bought by the gardener contain a total of 240 pounds of filler materials. Which equation models this relationship where X is the number of pounds of fertilizer A and Y is the number of pounds of fertilizer B? So I'm going to highlight this just with 2 different colors because we have some, what would you say, I guess some 2 different sets of data or values that we need to keep an eye on, if that makes sense. So we have fertilizer A here. It tells us that fertilizer A is represented, the pounds of fertilizer A is represented here by X. It tells us it also contains 60% filler materials. And then for B, B is represented by the variable Y here, or the number of pounds of fertilizer B is represented by Y. And that contains 40% filler materials by weight. We know that a sum total of these 2 contains 240 pounds. So we know that in this case, we should associate 60%, that value, and there's different ways to think about that number, 60%. We should associate that value with the variable X, and we should associate that 40%. Once again, you can think about that number 40% a few different ways too. Think about associating that 40% with the variable Y, the number of pounds of fertilizer B. So if I look at my answers, I mean, maybe it's a little bit preemptive, but if I look at, where am I at here? If I look at A and C, these are definitely not right, because if I look at the coefficients here, if I just take X, for example, right, they're grouping that 40%, the filler materials, onto fertilizer X, and that's not right. 40%, that number belongs to fertilizer B, so that can't be right. And then now it's just a matter between B and D. All right, if I look at this, B gives the coefficient on X, I'm just looking specifically at one variable now, gives the coefficient on X as 0.6. 0.6 is 60% as a decimal. So that makes sense. The number 60 and 60% are not the same thing. So if I look at D here, right, this is giving the coefficient of X, which is the number of pounds of fertilizer A, as 60. That's not correct. So B is a good answer. That makes sense. B is our answer. Okay, oops, that's why. Let's move on to number 3. We have a complex numbers and imaginary numbers type problem here. So it says, what is the sum of the complex numbers 2 plus 3i and 4 plus 8i, where I is equal to the square root of -1? So we want to express this, right? They're kind of giving us a word equation almost. The sum of the complex numbers, let me write this in red, do black. Sum of the complex numbers 2 plus 3i and 4 plus 8i. That's all they're asking for. So you can see that these parentheses don't really matter. And all this question is asking us to do really is just combine like terms. We can think about this I really as a variable, just like as if it was X, as if we had 2 plus 3x and 4 plus 8x. We know when we have like terms like that, we can combine them and we can add their coefficients in this case. So 2 gets added to 4, we get 6, and 3 gets added to 8, or 3i gets added to 8i, and we get 6 plus 11i. And they're not, if we look at our answers, right, none of our answers include this radical, the square root of -1. So we don't need to substitute it. I mean, we could, right? We know that this I here could be substituted for a square root of -1, but none of our answers require that. So there's no need to do it. And we see that this answer here, 6 plus 11i, is answer C. So that makes sense. Okay, number 4. In the equation above, P and T are constants. Which of the following could be the value of P? So if we look what we have here on the left side of the equation, this should stand out to us. Something about this. We have a squared term here, right? We have an x squared term, and more specifically too, this number 4 is a perfect square, right? It's 2 squared. So we have a coefficient on the x squared term that is the product of taking a number and squaring it, and that x value is squared, right? It's x squared. If we look over here on the right side of the equation, this 9, -9, but 9, is also a perfect square, right? That's the product of 3 squared. So that should kind of be priming us to be looking at a certain algebraic relationship here. And if we look on the right side of the equation, we have px plus t, that sum, multiplied by the difference of px minus t. And this should really jump out at us, right? This form is what we call a difference of 2 squares. It looks like we would have to FOIL this, like if we were going to write this out, you know. What we would get is we would get a p squared x squared, and then minus a t squared. We know that those inner terms cancel when we distribute this px to the negative t and this positive t to the px. They would cancel, so it's just the first term squared and then the last term squared with the negative sign, the minus sign there. So we can see that this p squared x squared minus t squared term fits perfectly onto this, p squared x squared minus t squared. That's my x squared. They tell us p and t are constants, and we're looking for the value of p. P takes the form of this, p squared takes the form of this 4 here. So p squared is analogous to 4, or equal to 4, we could say. Then p must be 2. Right? P is the, there's a lot going on here. P is the, right, the term here, the coefficient on those, and that's what we're looking for. So A is our answer there. Like I said, that representation, this should jump out to us. This something squared minus something that's a square minus something that's a square. That's a difference of two squares. So that should jump out to us. That's just an easy shortcut, I guess, or what's going on here? Something that they would definitely test on the SAT. All right, number 5. Which of the following is the graph of the equation y equals 2x minus 5 in the xy plane? So if we think about that equation there, x minus 5. Right, this is our simple y equals mx plus b form. So we can see that m, our slope, is 2, and it's positive. It's definitely important when we're looking at graphical representations of this to remember the sign. And b, our y-intercept, is negative 5. So these are two easily readable pieces of data, I guess you could say, about our slope here. So let's start off with looking at this m equals 2 part right here, our slope. So if our slope is positive, we know that overall the line, as we go from left to right, must go upward. So this instantly rules out b, right? This is a negative slope. It's heading downward. That's not possible. Could be negative 2, maybe, doesn't matter. The slope of 2 and negative 2 are two different things. So b, not correct. Let's look at a here. Yes, it's positive, but we can actually find out what the value of this slope represented in a is. We know that slope, our m, is equal to the rise over the run. So that's the amount that we either rise or fall vertically, divided by the amount that we go left or right, our run. So if I wanted to find the slope here, I want to pick two good points that clearly intersect at a given area. So it doesn't really matter, but this one stands out to me, and this one stands out to me. And if I look here, the rise that I have to undergo from one point to the next is definitely 1, right? I go up 1 unit here. So my rise would be 1. And my run, I go over 2 units, right? I run to the right 2 units. So my m here is 1/2. That's the reciprocal, right? That's the slope, that's the flip, the inverse of a slope of 2, but that's not what we're looking for. So A is not right either. Now it comes down to C and D. If I do the same thing here, right, I could check the slope. That would be a good way to make sure that both of these lines are eligible, let's say, for that equation. So if I pick 2 points again, let's go here and here. I can see I'm rising 2 here and running 1. So my m here would be 2 over 1, which is 2. So it checks that box. It does have a slope of 2. We'll look over here at D. The same thing is true. I'll pick this point and this point. I rise 2 and I run 1, right? So same thing, 2 over 1 gives me 2. So that also checks that box. So we have that other piece of information here, right? That our y-intercept is -5. So now that must be the difference between these two. We can clearly see they're parallel, they have the same slope, but these lines are starting from different spots off the y-axis. And so a y-intercept of -5 means that when our x value is 0, right, when we're on the y-axis, our y value is -5. If you look here at this one, this point here is 0, 5. This would imply a y-intercept of +5. It's not really +5, but I'm just drawing that here to, make that clear. So that does not work. So better hope that these are answer, and it works. We see here at this point 0, -5. That's our y-intercept, and that makes sense. That fits perfectly onto our equation of y equals 2x minus 5. Okay, next one, where are we at here? Number 6. If x equals 2/3 y and y equals 18, what is the value of 2x minus 3? So if we're ultimately trying to solve this, the value of 2x minus 3, we need a value for x, right? We need to find x. We can see that our value for x is tied up in this x equals 2/3 y term. So to get a number for x, we just have to solve the right side of that equation. We have to solve and find out what 2/3 y is equal to. We have a value for y, so all we need to do is just substitute. Substitute in here for y, we'll get a value for x, and then we can take that value for x and plug it into that expression on the right, the 2x minus 3, and get our answer here. So again, what we got, 2/3 times 18. This means that we're multiplying, right? It's 2/3 technically times 18 over 1. You can think about it that way if it's easier to see. You get 36 in the numerator, 3 in the denominator. That simplifies. 36 divided by 3 gives us 12. So our value for x is 12. Almost done. Just plug that in here. Our x value in that expression, 2x minus 3. So if I'm plugging in 12, 2 times 12 minus 3. I get 2 times 12, 24, minus 3, and that is equal to 21. That's my answer. That is answer A. All right, move on to number 7 here. A bricklayer uses the formula N equals 7LH to estimate the number of bricks N. They define that variable there. Number of bricks N needed to build a wall that is L feet long. So L is giving us our length, and H feet high. So H is giving us our height. Which of the following correctly expresses L in terms of N and H? So they give us that sample equation, let's say, N equals 7 times L times H. And we want to rewrite it in terms of, we want to express it as L. So this means that, right, we need to get L by itself, and we can see that that's the case for all of our answers. So that's the route we should go. So we'll take this one step at a time. L's over here, right? So it's being multiplied by 7 and by H. So I'll just do it one step at a time to undo. We'll do it all at once. Multiplying by 7 and H, I can divide by 7 and H, or I can divide by 7H. I divide by 7H here. Those two terms cancel. Divide by 7H here. I'm going to rewrite this with my L term on the side. On the left side, L is equal to N over 7H. So I'm looking for N over 7H. That's 7 over NH? No. H over 7N? No. C, N over 7H? Yes. And D, N over 7 plus H? No. So not D, not B, not A. Our answer is C. Okay. Number 8, I have a stranger one with the functions embedded in our table here. Number 8, the table above shows some values of the functions w and t. For which value of x is w of x plus t of x equal to x? So we're looking for a value of x where when we plug it into this function w of x, they spit out a number, and when we plug it into t of x, it spits out a number, and the sum of those two numbers is equal to x. Kind of a weird way to think about this. So let's kind of use a, not a guess and check strategy, but plug it in and see what happens. So if we look at this first row here, right, we're looking to see if w of x, this number, -1, plus t of x, -3, is equal to x, 1. Is that correct? Is -1 plus -3 equal to 1? No, that's -4, and that's not equal to 1. So no, that does not work. So that value of x, 1, is not true, and that's answer A. So rather than, go through each of the answers, let's just look directly at the table and see, by combining those second and third, or adding those second and third columns there, the w of x and t of x, adding those two together, like they ask us to do in our equation here. If that spits out an x value that is equal to the value for x that we plugged in into each of those functions. I know that's kind of wordy, but so let's look at the next one here. So if the second one is true, that means that w of x and t of x, those two numbers, need to be equal to the same value, or equal to the value of x that's in that same row. So in this case, 3 plus -1, is that equal to 2? Yes, that's true. So this makes sense. That works. That's our answer. Let's just look at the other two, 3 and 4, C and D. Just make sure these are, wrong, don't make sense. Here, if I get 4 and 1, I add those two like they tell me to do. I get 5. 3 and 5 are not equal to each other. So no, this does not work. And then the last answer, D, is for 4. 3 plus 3 gives me 6. 6 is not equal to 4, so no. Also does not work. B makes sense. No other answers are true. Let's keep moving here. Number 9 says if the square root of x plus the square root of 9 is equal to the square root of 64, what is the value of x? So we're looking for the value of x. It's in that radical. The square root of x plus the square root of 9 equal to the square root of 64. And we want to find out what this x is. I know it seems like what would make sense would be to do, well, let's subtract the square root of 9, subtract it over here, and then we'll square. It's going to get too confusing. Then we're going to have two radical terms, square root of 64 minus the square root of 9. We're going to be subtracting them, and then we're going to square them. It's going to get too hairy. And there's a better way to think about this. So we can just rewrite what this square root of 9 and what this square root of 64 are equal to, right? We're not doing any operation on the entire equation here, so that's fine. We can do this without violating any rules of algebra. So we have the square root of x plus the square root of 9 is equal to 3, and then the square root of 64 is equal to 8. Now this should look solvable to us. I can subtract 3 here, I can subtract 3 here. I get the square root of x is equal to 8. I'm sorry, is equal to 5. 8 minus 3 is 5. But I'm not looking for the square root of x, right? Because that would be answer B here, and that's not what I want. I'm looking for the value of x by itself, not square root x. So to undo the square root, I can square that side, square the right side. I get x is equal to 5 squared, which is 25, and I can see that that is answer C. Okay, number 10. Jamie is preparing for a bicycle race. His goal is to bicycle an average of at least 280 miles per week for 4 weeks. So that term, that phrase in there, at least 280, that jumps out to me. We know that at least can usually be modeled with an inequality. And if we look at all of our answers ahead, right, we can see that we have are greater than or equal to or less than or equal to signs there, so that makes sense. Okay. He bicycled, let me reread that second sentence. His goal is to bicycle an average of at least 280 miles per week for 4 weeks. He bicycled 240 miles the first week, 310 miles the second week, and 320 miles the third week. Which inequality can be used to represent the number of miles X Jamie could bicycle on the 4th week to meet his goal? So he hits 240 for week 1, 310 for week 2, 320 for week 3, week 1, 310 for week 2, and 320 for week 3. Now, X represents the number of miles that he hits for week 4. And if we think about this, we're looking for an average of 280, right? Our first one, 240, that's underneath, that's below the average of 280. But then we have 2 weeks, 310 and 320, and weeks 2 and 3, where we bicycle a number of miles that is greater than the average that we're looking to get. So, you know, our X value should be hovering somewhere right around that. What we're looking for, though, is an inequality that can model this. Which inequality can be used to represent the number of miles X Jamie could bicycle in the 4th week to meet his goal? So let's look at some of these answers here. If I look at A, you know, this looks like this is taking the average equation, let's say, or the average form, right, where we add up our individual amounts and then divide them by the amount that we have, right? So this is taking week 1, week 2, and week 3, adding them together, and then dividing by 3, and then saying plus X here, and that must be greater than or equal to 280. No, that doesn't make sense, because we're taking an average of the first 3 weeks, subtracting it from the average of 4 weeks that we'd like to get, and then ending it with X. That doesn't make sense. That's a misrepresentation of what we're looking to do here. B, 240 plus 310 plus 320 is greater than or equal to X times 280. No, that doesn't make sense either. That's right, X being multiplied by the average and then each of the individual weeks total mileage coming up there. That doesn't make sense. I mean, also if I added these up, what I get here, 630, I think this is 870. If I divide it by 280 here and divided that by 280, it's going to turn out X is going to be like greater than or equal to, I don't know, someone think about 3. That doesn't make sense, right? X should be the number of miles that he bikes in a week, and it should be on par, you know, with these numbers here, 240, 310, 320, and a value of 3 definitely would not get our average to that 280. So B does not make sense either. Okay, C. Oops. C, 240 over 4 plus 310 over 4 plus 320 over 4 plus X is greater than or equal to 280. No, that also doesn't make sense, right? We're taking each of our individual weeks, and these are our first 3 weeks, only our first 3 weeks, 240, 310, and 320, and dividing by 4. And then adding X, and that's equal to greater than or equal to 280. If X was over 4, that would make sense. But that's not what's happening, right? Because if X was over 4, we could put all those numbers up top. 240 plus 310 plus 320 plus X all over 4 is greater than or equal to 280. And yeah, that looks right. And if I actually look at D, that's what this would be, right? All D is doing is just multiplying that 4 over, right? Multiplying by 4 here. So D has it right. C is missing this denominator of 4 underneath x. So C is wrong. D has what we want. D is our correct answer there. Okay, number 11, a graphing question here. It says the vertex of the parabola in the xy plane above is 0, C. So our vertex here, give us a 0, C. Once again, our vertex is like the point of symmetry, I guess you could say, within a graph. So if you look at it here, right, we can see that's right here, 0, because we haven't moved off the x-axis at all. And C, that's just our y value, our y-intercept. Okay. Which of the following is true about the parabola with the equation y equals -a times x minus b squared plus c? So if I look at this graph, I need to realize, right, that what they're modeling here in this graph is this equation, y equals positive ax squared plus c. That is not the same thing as what they're modeling down here, right? What I can see here is that if I squared those terms, and it's going to get a little bit complicated between the x and the negative b in there. What's really important for me, though, is that first term and where this negative a, how it's going to interact with that x term. And know that if I distribute that, if I FOIL this squared term, this x minus b, and we get y equals, the x term that will come out will be x squared multiplied by a negative a, would give me negative ax squared, right? There's going to be a lot more to that polynomial. Doesn't really matter, though, because if I look at this equation that is represented here on the graph, right? This has a positive a here. And that graph opens upward, right? It looks like a U. It's I guess curving both ways upward, you could say. So this equation here means that it's opening downward, right? This negative a term tells me that. So let's look at my answers here. A, the vertex is B, C, and the graph opens upward. No, does not open upward. That's wrong. So A can't be it. If I find another answer that also says it opens upward, which C does, that also must be wrong. So C is not correct. So if I look at B and D, they both suggest that say that the graph opens downward, which is right. But the difference between B and D is that B says the vertex is B, C, and D says the vertex is negative B, C. That doesn't really make sense. And we know that the vertex, what is the right word to describe this here? The vertex of a graph like this, with this negative ax squared term, right? It's going to open downward. It's going to look something like this. Our vertex will be in the same spot. Turns out the vertex here is going to be the maximum value. In this case, right, it's the minimum value. So the vertex ends up being B, C. Let's move on to number 12 here. Which of the following is equivalent to, and we have a polynomial fraction here, 4x squared plus 6x over 4x plus 2. So if I look at all my answers here, I can tell that they've simplified it to some degree. Only C and D really have like some fractions left in them, and I can see in the denominator in both of them, I have my denominator here. So this is telling me that I'm probably going to have to do some long division here. No big deal. Let's set it up and see what we got. So I'm dividing my numerator by my denominator. My numerator here is 4x squared. Make sure I give myself enough room between each term, plus 6x. I'm dividing that by 4x plus 2. You don't see long division too often on the SAT, but definitely still a skill that we need to know how to do. So let's look at these first terms. The way we do this is we see our first term here within our fraction bar here. We're dividing that 4x squared by 4x. So the question is, when we divide 4x squared by 4x, what do we get? Right? If I do this just kind of, off to the side, 4x squared just by 4x, just those two first terms, I can see what would left would be x. So I need to put this x term up here, my answer, and then I need to write out what this x term distributed to this entire thing would be, and then take that away from what's in my dividend, what's in my fraction bar here. So if I multiply x by 4x plus 2, I get 4x squared. Good. X times 2 gives me plus 2x. I have to remember, though, I'm trying to divide, so I need to make this whole thing negative here. So I'm flipping the signs of all these. That's good. The 4x squared minus 4x squared, that cancels those two terms. When I make this a negative 2x, or 6x minus 2x, I get a remainder of 4x. I'm going to move this over a little bit. Get a remainder of 4x. And then I can go on another round here, right? So I'm going to try and divide 4x by 4x plus 2. Once again, we need to look at the first terms first. If I divide 4x by 4x, right? It's 4x plus 2 technically, but we're looking at the 4x's. I get 1, and it's positive 1, so it's going to be x plus 1 up top here. If you look at that, that's already starting to align with our answer D here, which is good. Turns out D is our answer, but let's finish this out. We need to kind of explain the rest of it. So if I multiply 1 by my 4x plus 2, I get 4x plus 2. Oops, I wrote that in the wrong spot here. Once again, I'm going to flip it, make it negative here. So those 4x terms cancel, and then, right, it's like plus 0 here, minus 2, right, that negative sign being distributed here. I get a remainder of negative 2. And then a way to write this is to take the remainder here and put that over your divisor. That's what that term is called here. Our divisor, or our denominator here. So I also have to take my quotient up here, my answer, x plus 1. And then I can write this as my remainder. I'm going to pull that negative sign out, that minus off of the negative 2, minus 2 over 4x plus 2. Perfect. That's answer D. Takes a little bit of time, those ones, but hopefully you can go through that a little bit faster. 13. This one's a little bit trickier. In the equation above, t is a constant. If the equation has no real solutions, which of the following could be the value of t? So that's a big hint here. Equation has no real solutions. Let's look at this equation here. 2x squared minus 4x is equal to t. That looks pretty similar to a quadratic equation of form where we have something squared, then plus or minus something x, and then plus or minus some constant c is equal to 0, right? So let's rewrite this equation like that. I have 2x squared minus 4x is equal to t. I'm just going to set this equal to 0, so subtract t here, subtract t. I get 2x squared minus 4x minus t is equal to 0. So the question is, which of the following could be the value of t? Now that would be kind of hard to do. I don't know. I don't think you can really factor that, at least not in any efficient kind of way. So what we want to do is evaluate something we call the discriminant. This is something that should look familiar. Our quadratic equation, the b plus or minus the square root of b squared minus 4ac over 2a. B squared minus 4ac is what we call our discriminant. There's a few different cases of what can happen when we find out what this whole term, b squared minus 4ac, is equal to. If b squared minus 4ac, whatever that would be, and if we realize, right, that b represents the coefficient here on our x term, a represents the coefficient here on our x squared term, and c is the constant, let me write them here, b, a, and c. We found out what this b squared minus 4ac was equal to. Like I said, there's a few different options. If it's equal to, if it's a positive number, there are exactly two real solutions to the equation. If it's equal to 0, there's one real solution to the equation. Or if the value is negative, meaning whatever we get out of this b squared minus 4ac, if it's negative, if it's less than 0, there will be no real solutions to the equation. And that's what we're looking for here, no real solutions. So what we can do is just set this being equal to less than or 0, right? We're looking for a value of t that enables or makes this discriminant b less than 0, makes it be negative. Once again, we only have values for a and b. Our value for c is t, and more specifically negative t. But that's okay, because we're looking for a value of t, and if we have 2 of the 3 variables known, the last variable t is what we're looking for, we'll get an answer that way. So let's plug in what we got. B squared minus 4ac, so like I said, my b term, I need to be careful here. My b term is not 4, it's negative 4. Negative 4 squared minus 4. My value for a here is 2. Then my value for c, once again, not just t, it's minus t. So negative 4 times 2 times negative t, that whole thing is less than 0. We're ultimately looking to solve for t, so let's start heading in that direction. Negative 4 squared gives me 16 minus 4 times 2 times negative t. 4 times 2 would give me 8 times negative t would give me negative 8t. This is minus negative 8t though, right, with this negative sign here. So it's going to end up being plus 8t. That is less than 0. Almost done here. Subtract 16, subtract 16. 8t is less than negative 16. Divide by 8, divide by 8. T is less than negative 2. Let's think about what this means here. This is telling me that that value for t, whatever's in that c place of my quadratic equation, needs to be less than negative 2. Now look at my answers. There's only one possible or potential answer that is less than negative 2. 3 is not less than negative 2. 1 is not less than negative 2. Negative 1 is not less than negative 2. But a, negative 3, is less than negative 2. So negative 3 is a potential value of t that would give us a discriminant that's less than 0, meaning we have no real solutions. So this question is kind of hinging on knowing this, knowing that we can use the discriminant, what this b squared minus 4ac term is, set it equal, or realize what it's equal to, it either being positive, equal to 0, or less than 0, and then see, see how many solutions we can get out of that. Let's keep moving here. All right, number 14. Let's read what it says here. A laundry service is buying detergent and fabric softener from its supplier. The supplier will deliver no more than 300 pounds in a shipment. So once again, that kind of looks like an equality. No more than 300 pounds, meaning my greatest value is 300 pounds. So it should be something less than or equal to 300, right? Can't go over 300. And if I look at all my equations here, right, they all follow that form. All my inequalities follow that form. So that's good, makes sense. Okay. Each container of detergent weighs 7.35 pounds, and each container of fabric softener weighs 6.2 pounds. The service wants to buy at least twice as many containers of detergent as containers of fabric softener. So we want our amount of detergent to be twice as great as the number of fabric softener. Let D represent the containers of detergent. D is our variable for containers of detergent, and S represents our number of containers of fabric softener, where D and S are non-negative integers. Which of the following systems of inequalities best represents this situation? So similar to that first problem that we opened up this section with, trying to think what that one was, right here. Number 2, right? Kind of a similar equation, right? We have one variable representing the amount of this thing, another variable representing the amount of that thing, and then their weights, and we're looking for a sum total. Like I said, we want to be able to match those two, the variables to their coefficients, let's say. So same kind of scalar idea here. I can see that my variable for D, detergent, should go with 7.35. That's the weight of a container of detergent. And 6.2 is my weight of a container of softener, so 6.2 should go with S. So that works out here, 7.35D and 6.2S. And here, C and D, no, this is telling me that my weight of a container of detergent is 14.7 pounds. That's twice the weight of a container of detergent. So that's just kind of a misreading of this buy at least twice as many containers. They're not saying buy containers that are twice as heavy. They're saying buying twice as many, buy twice as many containers. So C and D don't make sense. So we want to look for the differences between A and B. Look at A. D, which is our number of containers of detergent, is greater than or equal to 2S. So if we think about that, let's plug in a number here. Let's plug in a number for S. Let's say I buy 5 containers of softener. That's an S equal to 5. If I plug that in, right, 2 times 5, this tells me that D, my number of detergent, needs to be at least 10. Let's see if this fits the bill for what they're describing. They say the service wants to buy, right here, the service wants to buy at least twice as many containers of detergent as containers of fabric softener. So our amount of detergent should be at least twice as great as our fabric softener. Does this make sense? D, my numbers of detergent, containers of detergent is 10. Yes, that is at least twice as great as 5, right? It could be 11, 12, 13, beyond, but that works. But like here, this, might seem like it's the answer, putting the 2 on D, right? We should have more D. What happens is that actually kind of undoes it, right? This would tell us that for one amount of D, 1 here, times 2, we would get 2S. So this is a misrepresentation of that relationship. So A is our answer. And that's what we want. All right, number 15. Which of the following is equivalent to, we have in brackets here, in parentheses, A plus B over 2 squared? So you could, we have a sum of some variables here in parentheses, and we're squaring it. So if it helps, write it out. Right? We're squaring it, so we know we have one copy of it multiplied by another copy of it. We're going to do our FOIL, right? We're going to first, outer, inner, last, right? First, outer, inner, last. Without doing that, we know that the shortcut for FOILing means we take, if we're squaring something, we take our first term and square it. So our first term here is A. If I square A, I get A squared. To get the next term, I multiply my first and my second term. I multiply A times B over 2. A times B over 2 gives me AB over 2. And then I need to double it. So if I double AB over 2, I just get AB. And it's positive. Everything in this is going to be positive, so everything should be addition signs, plus signs. So I get plus AB. And then for the last term, same thing as the first term, I just square itself. So now I'm squaring. Now I'm squaring B over 2. And this maybe would be helpful to, you know, I guess write that out or sketch that out. I'm going to square the numerator and square the denominator. B to the first, which is what's there. B to the first squared gives me B squared over 2 squared. Technically it's 2 to the first to begin with. 2 squared gives me 4, so it's B squared over 4 plus B squared over 4. Let's see if this fits any of my answers. It does. This is answer D. Right, this is ignoring a term. This is also missing a term. This has that term, but forgot to double it, so that's wrong. D is our answer. Also, I mean, I know on the SAT, you can kind of be in a pinch for time, right? No, most people probably don't have time to look at all the answers that we said were wrong and make sure they're wrong. I'm just doing it now because we have the time to look at these, and you know, maybe you were thinking it was, in this case, let's say C. You know, if I can quickly point out why that one's wrong, then maybe that helps you understand this one a little bit more. But like I said, we don't really have the luxury of additional time on test day on the SAT. So, you know, if you did the work right on your question, getting your answer, you know, plug it in and keep moving. Maybe star that question and come back to it later on if you have time at the end of that section. But all right, number 16. Now we're moving into the grid in section. Number 16, if A to the B over 4 is equal to 16, for positive integers A and B, what is one possible value of B? This is kind of a strange question. So if A to the B over 4 is equal to 16, what is one possible value of B? So we know 16 is a perfect square, right? You know 16 is equal to 4 over 2, right? Squaring, I'm sorry, not 4 over 2, 4 squared, squaring 4. We know that 4 is also a square, right? 4 is the square of 2. 2 squared is 4. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So it is correct to say that 2 to the 4th is also equal to 16. So what I'm going to do is represent this 16 as 2 to the 4th. So A to the B over 4 is equal to 2 to the 4th. Now it says, for positive integers A and B, what is one possible value of B? So A is a positive integer here. If I'm representing or plugging in 2 for that position, that works. Now this tells me that, right, this B over 4 term needs to align with this 4 term, needs to be equal to it. So I can just say that B over 4 is equal to 4. I'm solving for B, multiply by 4, multiply by 4. B is 16. B is also a positive integer, fits that criteria. So yes, that makes sense. There's a few different answers that you could get for this question. Turns out the possible answers are 1, 2, 4, 8, and 16. And that's the case for a lot of these, maybe not a lot, but some of the questions in this grid-in section, there can be more than one answer, or at least more than one way to write your answer. That's just the route I went with it. So if you set up your A to the B over 4 this term as being equal to something else other than 2 to the 4th, then you know that's perfectly fine. So that's just the route I went with it. As long as it makes sense and your value for b is a positive integer, while you also kept a as a positive integer, that would have been fine. Okay, number 17. What value of t, looking for t, is the solution of the equation above? So we have 2/3 t is equal to 5/2. We're just looking for a value of t. So all you have to do is get t by itself. So here we're multiplying t by 2/3. So I could take this one step at a time. I could say, okay, well, to undo the division, I could multiply by 3, and multiply by 3 here, get whatever I get there, and then, oh, well, it's 2t now, I need to divide by 2, divide by 2. The easiest way to do this, really, just do it in one shot. Two-thirds t equal to 5/2. To undo multiplying t by 2/3, multiply it by its reciprocal, right? What undoes multiplying by 2/3? Multiplying by 3/2. So if I multiply by 3/2 here, I can see this 3 cancels there, that 2 cancels there. Now I just have to do it on the other side. Multiply by 3/2. See, this frees up my t term. So t, that's all I have left on the left side, is equal to 5/3, 5 times 3 over 2 times 2. 5 times 3 is 15. 2 times 2 is 4. So t is equal to 15/4. You could grid that in, right? You have to remember that you want to format these questions right. So if you were going to plug this in, I'll just say, do it right here, it'd be 15/4. So you could do that. That works. You could also think about what this is as a decimal. I mean, if I write this as a mixed number, I can see that this will be 3 3/4. So 3 point, and then 3/4 is 75%. It's 0.75. So this number can also be written as 3.75, and you could grid that in too. So either or, you could write it as 3.75 or 15/4. Either one works. All right, that was 17. Just keep moving. I think we'll maybe take a minute break once we finish this section here, section 3, before we move on to section 4. I know we've kind of been cruising through here. So look at number 18 next. Number 18. In the figure above, BD, I'm talking about segment BD here, we say it's parallel to segment AE. All right, we also know we have a right angle here, and given one of the postulates or theorems of geometry, we know we must also have a right angle here. What is the length of CE? So BD is parallel to segment AE. And I can see, right, there's similar triangles. If I have a right angle there, they're parallel. This angle must be equal to this angle. They've also both, this triangle CBD and CAE share this inner angle here. So I know that similar triangles, their sides, their lengths are proportional to each other. So I can clearly see that this side or length, leg, BD, is the proportional or corresponding side of this triangle here. The relationship is to go from this smaller triangle, CBD, to the bigger triangle, CAE. I need to multiply 6 by 3 to get to 18, right? That's right, it is. Times 3. So they want me to find the length of CE. They want me to find this length here, right? The whole thing. Now, if I see that length, CE, it's the hypotenuse of the big triangle. The side of that triangle that is proportional to would be the hypotenuse of this smaller triangle here, right? CD. CD is proportional to CE. So I need the value of CD, and then I know I can scale it up or multiply it by 3 to find the value to get to CE. So if I find CD, I multiply it by 3, I can get CE. So I could do the Pythagorean theorem here, right? I know I have some leg here called A, some leg here, that's 6, call that B. Looking for the hypotenuse, that's C. I know that Pythagorean theorem says A squared plus B squared is equal to C squared. I can plug those numbers in. Hopefully this stands out to you. 6, 8 as 2 legs of a right triangle. That's a triple. 6, 8, 10 is one of our Pythagorean triples. I believe that's what they call them. Or right triangle triples. 6, 8, 10. Meaning that my longest leg, 10, must be the hypotenuse. So C here is 10, right? That's also just a doubling of another Pythagorean triple, 3, 4, 5. Multiply 3 by 2, I get 6. 4 by 2, I get 8. 5 by 2, I get 10. Anyway, Pythagorean triples can save you a lot of time. I'm trying to think of some other ones off the top of my head. I think 5, 12, 13 is one, and maybe it's 7, 24, 25. I forget, but 3, 4, 5, and 6, 8, 10 are definitely ones that you want to know. And those are really good shortcuts to have on test day, especially when you get to geometry questions like this. Anyway, C here is equal to 10. That's really CD is equal to 10. And we said that CD is proportional to CE in the same way that BD was proportional to AE. We multiplied BD by 3 to go from 6 to 18. I'm going to do the same thing here. I'm going to multiply CD by 3 to get the length of this whole thing, CE. So CD times 3 will give me 30. 30 is the length of CE, segment CE. That's a classic kind of SAT geometry question. Similar triangles being proportional and having like a right triangle embedded in another right triangle. All right, number 19. How many liters of a 25% saline solution must be added to 3 liters of a 10% saline solution to obtain a 15% saline solution? So kind of a strange question, right? We have a stronger, more concentrated saline solutions, 25%. We need to find out how many liters of that, of the stronger stuff, we need to add to 3 liters of the weaker stuff to get to some concentration that's in the middle-ish. 15%, yeah, it's between 10 and 25. So we're gonna add a certain amount of the stronger stuff to the weaker stuff to get something in the middle there. So how can we express this? Well, let's think about what we're trying to find. We're trying to find liters of a 25% saline solution. How many liters? We can represent that as X. You need to be careful. X is the number of liters of the 25% saline solution. Doesn't apply to both the 25% and the 10%, just the liters of the 25% saline solution. I'm taking 3 liters of the 10%. And overall, I'm going to obtain a 15% saline solution. An important question to ask yourself is, assuming this setup here, how many liters of the 15% saline solution will we finish with? Well, we're not going to get an exact number because we don't know, right? Part of the number of liters of this 15% saline solution, that volume, the amount of liters of the 15% saline solution, is the volume that we'll have by combining the 25% solution and the 10% solution. The volume of 25 was X, and the volume of the 10% was 3. So the total will be X plus 3, right? It's not an exact number. It's not known, but that's all right. So let's try and represent this, right? The amount of saline that we'll get from the 25% solution should be equal to the volume of that solution that we're using, in this case, X liters, multiplied by the concentration of that solution. Once again, we don't want to use 25%, right? In that earlier question, we don't want to plug in 25 here as a coefficient or something that we're multiplying X by. We want to convert this 25% to a appropriate number as 0.25. Same thing with this 10%, that's going to be 0.1, and 15% is going to be 0.15. You need to take that into account, otherwise we might get some inflated numbers here. So let's put this all together here. X is our number of liters of the 25% saline solution multiplied by the concentration or the strength of that solution, 0.25. We're adding that to 3 liters of the weaker 10% solution. That will be equal to this final concentration, 0.15, the 15%, times the volume of that middle ground or medium concentration solution, which we said that volume here was equal to X plus 3. Okay, so we have an equation here. There's a few moving pieces to it, but we only have one unknown variable, X, and we can solve for that. So let's go ahead and do it. So X times 0.25 gives us 0.25X plus 3 times 0.1 gives us 0.3. That's equal to, we distribute this 0.15 onto each of these terms, we get 0.15x plus 3 times 0.15 gives us 0.45. Again, this is a non-calculator section. We want to be able to do those in our head, and we can see that, right? This looks like 15 times 3. 15 times 3 gives me 45. If I bring in the decimal, 0.45. Okay, now just combine like terms. So I'm going to subtract 0.15x here. Subtract 0.15x here. I get 0.1x, or 0.10x, same thing, plus 0.3, that's equal to 0.45. I'm going to subtract 0.3, subtract 0.3, get 0.1x, almost done, equal to 0.15. Now I need to divide by 0.1. Do that on both sides. Divide by 0.1. I divide 0.15 by a small number, right? 0.1 is a tenth. What I'm actually doing is multiplying 0.15 by 10, right? If I'm multiplying or dividing by a fraction or a number, same thing as multiplying by its reciprocal. So dividing by 0.1 would be the same thing as multiplying by its reciprocal, which is 10. Anyway, you can do that mentally. X is equal to 1.5. That's the number of liters of my 25% saline solution here. X is equal to 1.5. Makes sense, right? We had 3 liters of this, and yeah, that sounds about right. All right, last one in this section here. Erase this. Okay. 20. Oh, and once again, let me just make that point here. For this one, you grid in that answer 1.5. If you feel more comfortable representing it as a decimal, you could. I'm sorry, as a fraction, you could. 1.5, right? That's the same thing as 3/2. So if you want to grid it in that way, you would just do 3/2. Both are correct. They'd give you credit for both. Number 20, points A and B lie on a circle with radius 1. An arc AB has length pi/3. What am I saying here? Has length pi/3. What fraction of the circumference of the circle is the length of arc AB? Point A and B lie on a circle with radius 1, and the arc between them, the curve of the circle, the little sliver of the circumference, AB, has length pi/3. What fraction of the circumference of the circle is the length of arc AB? So let's draw what we have here. A little radius there, call it R. It's a not great circle. Let's say A is here. It's hard to estimate this, but it doesn't really matter. B, put it there. They tell me that my radius is 1. So if I draw that line here, that's 1. That line here, that's 1. More importantly, though, what we can do with that radius of 1 is we know that the circumference of a circle is equal to the diameter times pi. And we know that the diameter of a circle is equal to 2 times the radius. So I plug this in and just do it all in one shot here. The circumference of my circle is equal to 2 times the radius of my circle times pi. 2 times my radius of 1 times pi gives me a circle with a circumference of 2 pi. So, question says, what fraction of the circumference of the circle is the length of arc AB? So they tell us arc AB has a length pi/3. Pi/3 is this this area here, right? It's that curved sliver, that section of the circumference is pi/3. What fraction is pi/3 over the circumference? My circumference is 2 pi. So what is the fraction that is pi/3 over 2 pi? Well, we can do that. So we put pi/3, and that's over 2 pi. Again, that's to me, that's a less than ideal way of writing that to evaluate it. So I just try and kind of talk myself through it. If I divide pi/3 by 2 pi, once again, dividing by something is the same thing as multiplying by its reciprocal. So dividing pi/3 by 2 pi is the same thing as multiplying by the reciprocal of 2 pi. The reciprocal of 2 pi would just be 1/2 pi. To me, this is a lot easier to think of. The pi will cancel. I still have an invisible 1 left over there. 1 times 1 gives me 1. What's left in my denominators is 3 and 2. 3 times 2 gives me 6. And that's it. That's my fraction. 1/6. Now for that, 1/6 turns out is a repeating number, right? It's 0.16666666666. Obviously, I don't have an infinite number of spaces to grid in my answer. So to me, it makes more sense to grid in 1/6. Or you could write it as decimal here. They take 0.166 or 0.167. These are each of these, that, or that are all correct answers here. Okay. So let's take a quick 1-minute break, a little stretch. We got about 15 minutes to go. See how many questions here in section 4 that we can knock down, and then we'll call it a day. Once again, this is the calculator section too, so if you want to get your calculator ready, we'll lead off here with number 1. Just take a minute, and then a quick break, 1 minute break, and then we'll start back up. Another 30 seconds, stretch out. Hopefully maybe we can get the first 5, 7 problems done, something like that. All right, here we go. Number 1, which expression is equivalent to, in parentheses, we have 2x squared minus 4, and minus, in parentheses, negative 3x squared plus 2x minus 7. So all we need to do is combine like terms, right? We're not looking for an answer. We just have an expression. So all we need to do, though, is just really be careful. This negative sign is getting distributed to everything here. So it gets distributed to the negative 3x squared, gets distributed to the 2x, and it gets distributed to the negative 7. A kind of helpful tip that maybe this will help you understand it, that I remember doing in high school algebra. When you have that negative before the parentheses, you can say that this is plus, and then there's a negative 1 there. So it would be like plus negative 1 being distributed to everything in here, negative 3x squared plus 2x minus 7. So if that helps you see it this way, to me, this is a little bit more obvious, right? It's like, okay, I'm distributing this negative 1. I'm not just, how can I distribute a sign? I'm distributing a sign, negative, on a number 1. So they're the same thing. They're both true, but they're both correct. If it's a little bit more helpful for you to see it that way, do it that way. But either way, you have to take care of that. Take care of that negative sign. Otherwise, we're going to get the wrong answer here. And I'm sure one of these answers too has the answer that you would get if you did not distribute that negative sign too. You know, the SAT is crafty and misleading you. So let's see what we have here. I'm going to write this 2x squared minus 4 term here. Just writing it outside of the parentheses. And then that negative sign being distributed there, that is going to, negative sign to a negative 3x squared will give me positive or plus 3x squared. Negative sign to the positive 2x will give me minus 2x. And then the negative sign to a minus 7 will give me plus 7. Now we just need to combine like terms. I have an x squared term here and here. I only have 1 x to the first term here, and then I have 2 constants with no variables attached to them. So 2x squared plus 3x squared gives me 5x squared. All right, that automatically knocks off C and D. If I didn't do that, right, if I did not distribute this, I would have gotten negative 3x squared. If I just left it, if I didn't change it, 2x squared minus 3x squared would give me a negative x squared, right? So that they already account for that. They're already, you know, priming you for a wrong answer there. So take your time with that. Okay, so I get 5x squared. Instead, that knocks off C and D. Next term, minus 2x. There's nothing to simplify there. So I can see that automatically eliminates B. That's a plus 2x. That's wrong. And then minus 4 plus 7 gives me plus 3. That's what's left. And that works here, here, here. That's correct. A is my answer. All right. Number 2. Let's see if I can zoom out and get this all in the picture here. Yeah. All right. The graph above shows the positions of Paul and Mark during a race. Paul and Mark each ran at a constant rate, and Mark was given a head start to shorten the distance he needed to run. Paul finished the race in 6 seconds, and Mark finished the race in 10 seconds. According to the graph, Mark was given a head start of how many yards? It's going to tell us Mark was given a head start. And if we see this, it kind of makes sense. Given the graph, I mean, it should make sense, right? Paul is starting from, this is Paul's line here. Let me do yellow. Paul's line here is in yellow, right? He's starting here at 0. He's starting where you would expect to normally start a race. Mark here is starting at this point here. They're both finishing at the same spot, right? So up here, we can tell that this is the finish line. Here, this would be like the normal starting line. We're trying to make sense of this graph. This is the normal starting line. But this right here is where Mark's starting from. Paul finished the race in 10 seconds. Paul finished the race in 6 seconds. Paul finished the race in 6 seconds. Mark finished the race in 10 seconds. According to the graph, Mark was given a head start of how many yards, right? So his head start is the difference between where Paul started and Mark started. I mean, if we think about it, if Paul started 5 yards in front of the finish line too, like let's say maybe somewhere right here, Mark's start is not just the Y, his head start's not really just the Y-intercept. His head start is the difference between the two. It just so happens that Paul is also starting here at the origin. He's starting at 0. So Mark's head start is equal to the Y-intercept here. We can see that the Y-intercept on his graph right? It's directly between 12 and 24, right? The number that is directly between 12 and 24 would be 18, right? If I go here, 2 units becomes, right, 2 blocks, like 1 unit there becomes 12. Then that means 1 unit must be 6. 6 added on to 12 gives me 18. So Mark's head start was 18 yards. Correct. That's definitely not right. And that's too low. That's too low. And 24 is too high. Okay. So try to get a couple more in here. Number 3, snow fell. That's an appropriate question. Snow fell and then stopped for a time. When the snow began to fall again, it fell at a faster rate than it had initially. So if I look at these graphs, I can tell I'm trying to like map out a good visual representation of my snow accumulation over time. I can see I have accumulation here on the y-axis, right? The buildup of the snow, how much snow you accumulate or have with time. So let's reread that descriptive introductory sentence that tells us what this progression of weather looked like. It says snow fell and then stopped for a time. So if snow is falling, what should this look like on the graph? Snow should be building up, right? We shouldn't have, if we have a graph of accumulation, we're not starting with accumulation, right? This would be like implying snow is already on the ground and we're here. It also wouldn't be starting and going up. We need to start from 0. And accumulate to some degree. Now we don't know exactly how steep that should be. They don't tell us that we only accumulated an inch, or they don't tell us that we only accumulated a foot, but it doesn't matter. Say it fell and then it stopped for a time, so that's important. If it stopped for a time, we are not increasing our amount of accumulation. We still have that same amount of accumulation. That doesn't mean we're dropping. It just means that where we're at is kind of plateauing, right? For some bit. So all these graphs have that except D. D is just saying that the snow just keeps on going. C has a brief pause. B has that brief pause. A has that brief pause. Look at the difference between A, B, and C. We can see that the difference in these graphs are going to be what the difference is when the snow must resume or disappear, right? We can see C, the accumulation drops. It's going downward. The accumulation is falling. I guess that would imply the snow is melting. With B, if I see here, right, what's important to consider here is the slopes. The slope of this graph, it's the accumulation over time, right? It's my rise over my run. It's really how fast the snow is falling. A steeper slope would mean that more snow is falling in a smaller amount of time here, and in this one, less snow is falling in the same amount of time. So this is like faster snowfall here, and this would be slower snowfall here. That's B. Like I said, C is implying like melting, and A, my snowfall is here for the first part, plateaus, and then if I look at this, like I said, this slope is definitely greater than that slope, right? This slope here is definitely greater. So this graph for A implies that the snow was falling, stopped, and then when it resumed, this second snowfall, the rate of the snowfall was greater than the first. So the slope here is really what's crucial to understanding, you know, what this representation looks like. So let's look at the question. When the snow began to fall again, it fell at a faster rate than it had initially. So this is telling us that this second snowfall should be greater, should be more dramatic, should be more rapid. Definitely that's not C, right? This is saying that snowfall is dropping. That's wrong. Between B and A, which one has the graph where the second period of snow is greater than the first? Well, that's definitely A, right? My slope of my snowfall is greater than B, right? B, it's sharp and then plateaus and then it picks back up, but it's not as sharp as it was originally. So B is wrong, A is our correct answer. Keep moving, try to get a couple more done. Maybe get to 5 and call it a day. Number 4, a website hosting service charges businesses a one-time setup fee for $350 plus D dollars, or I'm sorry, for $350 plus D dollars for each month. If a business owner paid $1,010 for the first 12 months, including the setup fee, what is the value of D? So this actually is very similar to another question we did earlier. I think it was the first one, Salim and the tickets and the one-time fee or the service fee, something like that. This one-time setup fee should be standing out to us. This is almost always or really most easily modeled as a y-intercept in a graph. And this should be a constant linear function, right? They tell us that setup fee, that's fixed, and then D dollars for each month. So D dollars for 1 month, 2D dollars for 2 months, 3D dollars for 3 months, and so on, right? So I could say that the amount of money I'm paying my bill is equal to let's see if it's the right way here. Well, let's just fill in what we have here. I'm paying $1,010. And they tell me that this was for 12 months. So 12 months times the amount that I pay each month, which is what I'm looking for, D dollars for each month, and my setup fee. No coefficient on the setup fee because it's just a one-time fee, right? If I only had my service for 1 month, I still got to pay it. If I had it for 2 months, I got to pay it. If I had it for 1,000 months, I still got to pay it once. So anyway, I'm looking to solve for D. Subtract 350. It's technically dollars, but whatever, the dollar sign doesn't really matter here. Subtract the dollars. What do I get there? That should be 660. So you can use your calculator on this section. That's equal to 12D divided by 12, divided by 12. That should be 55. 60 divided by 12. That is 5 and 66, 65. Yep, 55. So D is equal to 55. That's my rate or the amount that I get charged each month. That's my value of D. Number 4, that is answer D. All right. So it's 11:59. Let's stop there. I mean, I think we tackled a bunch of questions there.
Okay, so thanks for watching, and please remember to contact us at info@embracetutoring.com to set up any personalized private tutoring sessions you would like. Stay tuned for future videos, and best of luck with your studies. We definitely encourage you to visit our Instagram as well as TikTok pages if you have any questions along the way. Take care, guys. Best of luck with your studies.